Hello, everybody, and welcome to tonight's webinar. My name's Helen Stewart. I expect most of you have seen me here before, but there may be those who haven't. I understand there may be some members here from the Dali Curlew project, so welcome to those people if you're out there somewhere. I'm just going to run through one or two small details about how the webinar will run before introducing our tonight's speaker, who we're very excited to have. So in a moment, I will be handing over to the speaker. What we'd like you to do as you listen to the talk, if questions do occur to you, if you could pop them into the Q&A, you'll see a Q&A button at the bottom of your screen for those of you who aren't so familiar with Zoom. If you just click on that button, you'll be able to write your question into the Q&A. The reason we do things that way is so that Jeff can sort of collate the questions, put them in a sensible order and ask them to the speaker at the end of the meeting. So if you wouldn't mind doing that, that would be marvellous. So without further ado, let me get to our speaker. We're very fortunate to have Samantha Franks with us tonight. Samantha is a senior research ecologist at the BTO. She's focusing on exploring how our changing environment is influencing bird populations, and in particular waders. We're especially interested, of course, in these parts in curlews and lapwings, and I expect we will be hearing a little bit about both of those species as the talk goes on. Sam has worked for a number of years in the Alaskan Arctic, which sounds extremely exciting. She joined the BTO in 2013, and she's leading elements of the BTO's breeding wader research at the moment, with a special focus on curlew. She represents BTO at national curlew forums, and she's supervising a PhD project investigating landscape scale conservation management for breeding curlew in Bretland. And she also leads BTO's role in the Eastern England Curlew Head Starting Project. And her talk's going to cover the causes of curlew, and I guess probably also other wader declines, and how research on curlew and other waders is contributing to informing the future of wader conservation, especially in the UK. Okay, so without further ado, I'll pass over to you, Sam. I'm looking forward very much to the talk.
Thanks very much, Helen. I will just share my screen. Hopefully everybody can now see a bunch of small waders flying around and the title slide of my talk. Thanks very much for inviting me to talk to you this evening. It's a real pleasure, especially I don't often get to talk to more northerly based groups, particularly ones where curlew are more sort of prevalent into the surrounding area. So it's a real pleasure to speak to Wharfedale Naturalist Society tonight. I had the pleasure of visiting Wharfedale quite a number of years ago now, getting on for probably about 8 years, but it was a very pleasant experience in April. So tonight I'm going to speak to you about BTO's work working towards a brighter future for waders. The title of this talk is kind of morphed from curlews in crisis now towards a slightly more positive and optimistic tone, because I think while curlew and other breeding waders in the UK are still in very big trouble, there is hope on the horizon, particularly because a lot of people are working in particular together to improve the fortunes of curlew in this country and other waders as well. So many of you will have seen a slide or something similar like this before, which is a really stark visual depiction of the declines of our most common breeding waders in many parts of the country. And many of you who are BTO members or supporters might have supported our curlew and Operation Wader appeals, which we've run over the last 6 or 7 years or so. And this is when we launched a really more concerted research program to understand the population declines of the UK's most iconic breeding wader populations. Let's see if I can get my talk to advance. There we go. And Curlew is where our most recent focus began. And over the past 20 years or so, the UK lost over half of our breeding curlews. That's over 100,000 individual birds, if you kind of tot them up from what they were before the decline started. And in 2015, it was added to the UK's Red List of Conservation Concerned, where it very firmly remains a good 7 years later. Curlew breed across Europe, but they're declining across much of their range, and so they're red listed as a consequence. And the UK has a particularly unique role to play in curlew conservation, and rather a moral imperative as well to conserve curlew in the UK, because it has one of the largest populations in Europe at about 59,000 breeding pairs. But it also has one which is the most quickly declining, as you can see by the sort of the darkness of the red arrows on the map. The darkness of the red shows the kind of the extent of the decline, with the darker colors being more quickly declining populations. In the British Isles, curlew are most abundant in the uplands, as I'm sure you'll very well know where you're based, breeding predominantly on moorland bog, heath, and nearby grassland habitats like Inby grassland. And the strongholds are very much in northern England, so the Pennines, particularly eastern Scotland and the Northern Isles. But there's also plenty of small populations of breeding curlew which remain in lowland areas across Scotland, England, Wales, and Northern Ireland. So if you take the bird atlas from 2011, we look at changes in numbers using the atlas data from 1990 to 2010. You can see on the right, these kind of blue areas show really extensive losses in numbers throughout much of Ireland, Wales, and Scotland, with the sort of downward black triangles showing tetrads where curlew completely disappeared between the 1990 and the 2010 atlas. And the range contracted by nearly 8% in Ireland and between 15 and 20% in Britain. And, you know, there's a few orange splodges on the map which show increasing populations, but these small, really quite small gains comparatively don't compensate for wider losses throughout the British Isles, particularly in areas where there's really stronghold populations of curlews, so quite large populations being lost. And so that's just an example for curlew, but of course BTO's long-term monitoring data sets show the extent of declines is really across the board for many of our wader species, particularly lapwing, to a certain extent oystercatcher, although there's sort of differentiating trends in England versus Scotland, redshank, and snipe is maybe one where the picture is a little bit more clear, perhaps stable, perhaps increasing or decreasing in certain areas, but snipe are quite difficult species to survey, so that's a bit harder to say. So what are the reasons for these by and large extents across the board, declines across the board? If we look at curlew in particular to focus on, we look at our other long-term monitoring data sets, particularly the BBS, Breeding Bird Survey. We see how the population has changed over time. And since the mid-1970s, like many other species associated with agricultural habitats, they've undergone a dramatic decline, largely linked to changing farmland practices. And unlike some other species, which might be doing better in some parts of the UK than others, so oystercatcher being an example, these declines are really across the board for curlew, being seen in England, Wales, and Scotland. So what are some of the reasons for those declines? Well, in terms of demography, so the demographic factors driving changes in abundance, wader numbers are the product of breeding success on the one hand, which combines the survival of both nests and chicks, and the survival of adults and juveniles. Now, adult survival of many waders is quite easily calculated from bird ringing studies, and many of the species, breeding wader species in the UK, we have reasonably decent estimates for adult survival, which for most wader species is fairly high, particularly for the large-bodied species like curlew and oystercatcher. So that's 90% for curlew annual survival. So that just means that every year, 9 out of 10 curlews still alive are expected to survive until the next year. Juvenile survival is another question entirely, quite a lot more unknowns around that estimate, which I'll come to in a moment. But there's a lot of evidence to suggest that adult survival is really not the problem for curlew. It is very much poor breeding success. And curlew stability, we can look at sort of population growth models, and a stable population means that a breeding pair of curlew needs to produce about 2 fledged young every 3 years. But in reality, in many parts of the UK, it's more like 2 chicks every 6 to 10 years. So very much like half what they need to be producing, or perhaps even less than that. But what are the drivers of this decline? Well, habitat loss and degradation is one of the primary drivers of decline. And in lowland and many marginal upland areas, the primary cause is from agricultural intensification, as I mentioned earlier. So that's changing farmland practices largely. And an example of this could be the conversion of natural grasslands into arable habitats. And this can lead to the complete outright loss of nest sites. And given many waders are incredibly site faithful to their nesting sites, birds might just abandon breeding attempts entirely. Alternatively, it can lead to failed breeding attempts, where even if nests hatch into an arable landscape, there is little food for chicks available, meaning they either have to travel a really long way to find food, or they make themselves more obvious to predators while trying to find food for themselves. So intensification can also take the form of grassland improvement, and I put the improvement in quotation marks, from damp, rough grassland, which might be quite insect rich, to a species or species-rich hay meadows, things like this, to a very uniform, intensive ryegrass monoculture cultivated for silage. And I'm sure where you live, you probably are all familiar with quite extensive silage landscapes because they're quite predominant, in particularly the lower areas of many of the dales in Yorkshire. And so while technically the nesting habitat might still be appropriate in quotation marks, so it's grass, it might be inappropriate for both nest and chicks. So it can be the wrong structure for nests, or it's too dense and tall for chicks to forage in. In addition to the lack of vegetation diversity through this conversion to a ryegrass monoculture, the intensification can also bring with it increased drainage. And both this lack of diversity and the drier ground as well means less invertebrate mass and diversity, and therefore less food for chicks. And this type of improvement can also mean, as I mentioned, a conversion of hay to silage, and often that brings with it a more intensive mowing regime, and particularly with warmer springs, advancing springs due to climate change, then the frequency and the date at which cuts are taken can really be quite incompatible and very destructive for curlew nesting attempts. And so consequently, many nests are lost to agricultural machinery, either nests and or any chicks that potentially might get away as well. In uplands and marginal upland areas, afforestation and peat extraction can result in the outright loss or degradation of core breeding habitat, and there's increased drainage as well, which can result in habitat degradation, with again poorer food quality for chicks as a result of drying out of sites. And afforestation also has the additional knock-on consequence of harboring potential mesopredators like corvids and foxes, which can then act as a predator reservoir going out into the landscape to then look for food in the more relatively food-rich open landscapes around forested areas. So on that topic of predation pressure, there's a substantial amount of evidence to suggest that it's the predation of nests and chicks really that's probably the single biggest factor which is hampering breeding success for waders around the country. So while this is undoubtedly the primary proximate driver of population declines, it's a symptom of wider problems in the landscape. So there's a large number of generalist mesopredators in the British landscape. Various studies have shown this. A recent study from the UK has shown that the UK has some of the highest densities of these types of predators. So things like corvids, foxes, and stoats and weasels. So generalist mesopredators as opposed to apex predators like wolves and lynx and those sorts of things. The UK has some of the highest densities of these mesopredators of any European country. And why is that? That's one of the things we have to find out to try and address this problem of predation pressure on breeding waders. So I've also mentioned that habitat degradation can make nests and chicks more susceptible to predation. So it can make nests easier to find in a less structurally complex landscape. It can cause chicks to behave in ways that make them more susceptible to predation. So this one here is hiding, or they can spend more time feeding and less time hiding if they're hungry, or they can be out in landscapes like this one, feeding in really short grass habitat where they're very vulnerable to predation. So while it can be a controversial subject, the reality about predator control in particular as a means of addressing this problem about predation pressure is, it's a controversial subject, definitely recognize that. And people feel very strongly on both sides of the argument, if you like, on both sides of the debate. But the reality is that there's evidence to show that it can act as if anything, a short-term kind of sticking plaster solution to reduce predation pressure, assuming it is done in a legal, proportional way. But it is deployed as just one measure in a suite of tools. It's quite logistically difficult and it's expensive to roll out at sufficient intensity and scale across the wider landscape. And so that's why I say it's a short-term sticking plaster solution, because it's not the way forward for really sustainable conservation management approach at a large scale for over long periods of times, because it would just be too logistically difficult to deploy. It really requires, it has to be done at a high enough level and at the right times of year. It requires trained and competent practitioners, which follow really best practice, but it's not always effective in all situations. So it can, its effectiveness can depend quite a lot on predator densities, predator types in the landscapes, and how predators move around the landscape. So despite what other things might be said about upland grouse moors, it is true that game bird management and the associated intensive control of predators has been shown in various scientific studies to benefit breeding curlew and other waders, particularly in terms of increasing their breeding success. A good example of this one is the Otterburn study led by GWCT. So while there's quite a lot of discussion about, illegal raptor persecution and so on associated with game bird estates, when game bird management is done well and legally, it can have a beneficial knock-on consequence for not only game birds like red grouse, but also other ground nesting birds like waders, which breed in these areas. So predator exclusion is, instead of predator control, is an additional measure that can be used to deal with predation pressure on ground nesting birds. So for example, you can use fences to either protect nests, and if done at a large enough scale, like this fence on the Dean washes in the Cambridgeshire Fens, which is deployed as part of Project Godwit. It can benefit chicks as well. But again, like predator control, really logistically difficult, expensive, and really pretty much impossible to roll out at scale across the countryside. Fundamentally, you can only protect either at nest scale or at sort of small sort of study site scale. So ultimately, solving this predation pressure problem is going to mean dealing with the questions surrounding why there are so many predators in the British landscape, and also on improving habitat quality sufficiently to a point where nests are in more favorable landscapes and are therefore better protected by virtue of the fact that they're harder to find by predators. And similarly, chicks have some place to hide and also sufficient food so that they don't make themselves as vulnerable to predation. So it's a really tricky question to answer. Various organizations are looking at it, and it's a matter of addressing why there's so many mesopredators in the landscape, what is driving that, supplementary food sources like urban areas and game birds and roadkill that comes as a consequence of released game birds into the countryside are some of the potential causes that have been proposed. And I think all are potentially very likely, but it's going to take quite a lot of very detailed work and to sort out what is the answer to a very complex question. And I'm sure the answer will not necessarily be clear, and we might not come to a sort of conclusive answer. It might be a little bit of everything. And undoubtedly, it will be very difficult to solve. So moving on to climate change. After the summer that we've all had in the UK, particularly down here in Eastern England, where I think it didn't rain around us for about 2 months solid, climate change is very much at the forefront of everyone's mind and is another factor which can potentially impact our breeding waders. And so this is some modeling work that was done by the BTO by about 10 years ago now. And these maps show the change in the density, so the number per square kilometre of breeding curlew between 1997 and the projected density by 2080 as a result of global warming. Which really shows curlew in their densest areas contracting up into the uplands and the sort of very highest reaches of the uplands, if you like. So climate change has the potential to reduce the suitability of habitats, both upland and lowland habitats, because of summer drought. And this can either reduce the available time that chicks can be out foraging rather than seeking shelter. My PhD student has found some evidence that curlew chicks, because they go out and they forage themselves for food as soon as they're hatched, they're not fed by the parents. When temperatures are above 25 degrees Celsius, which it is often in the summertime in Breckland, they spend a lot of time underneath the nearest amount of tall vegetation they can find, whether that's a small bush or a bit of tall vegetation, sheltering rather than out feeding. So they seek shade. And so these warm temperatures can also reduce food availability, increase the risk of moorland wildfires, which I'm sure where you're based, you're acutely aware of, and can also increase the start and the frequency of silage cuts, which I mentioned earlier. So this is a very broad brush picture of the main factors which are affecting breeding waders across the country, with habitat change and predation pressure probably the two biggest immediate issues, but climate change really rising up the agenda quite quickly. And their relative importance is likely to vary regionally, and even at quite small scales. You know, people think that you know, in a certain area, so say like, you know, Eastern England or the Pennines, the issues most pressing for curlew are likely to be quite similar, but it can vary at quite small microscales, in fact. So I think that's important to remember. There's not going to be a broad brush solution that can be applied everywhere. And the solutions to reversing declines and enhancing breeding wader populations are likely to be quite bespoke between areas. And so there's a huge value as a consequence in local studies, because the relative importance of these factors can be quite dependent on different habitats and landscapes that they're in. And these local studies can tell us more about how local populations are doing and what the mechanisms are that are most important in affecting those populations, and therefore what the most effective conservation solutions are and why, or in other words, what works where and why. So the good news for curlews and other waders is that there's a lot of people and organizations on the case to recovering their populations, both in the UK, but also in Ireland as well. And there's a host of formal and informal partnerships that have been initiated in the UK countries. In Scotland, we've got Working for Waders. We've got the Gulvanir Cymru or Curlew Wales in Wales, and then the Curlew Recovery Partnership in England. And the aim of these groups is, yes, as an information sharing forum among all the different organizations and government agencies with an interest in curlew. And, you know, this is definitely a very active area of interest. But importantly, it's a way of connecting researchers with conservation practitioners, local community groups, policymakers, and other stakeholder groups that have an interest in curlew. And so that everybody is kind of working towards the same goal and singing from the same hymn sheet. So over the last 5 years, there's been a massive proliferation of studies across the UK and Ireland, really since curlew were red listed in 2015. And we summarized a lot of those in a now quite outdated audit in 2019. You know, a whole number have popped up in since then. And I heard Jeff mention, or Helen mention, I think, the Darley Curlew project, which I'll probably ask for more information about shortly at the end of the talk. And these can range from local community-led projects to ones led by NGOs or university projects, and really everything in between. And many of these are collaborative partnerships. They're often spanning multiple different stakeholder interest groups, and they provide a real exemplar of what can be achieved by working together for waders. And I'll just give a brief tour of some of the ones that BTO are working on and working with. So our first stop is in Eastern England, where we are engaged in two different projects. And the first I'll touch on is a joint PhD project, which Helen mentioned in my intro, together with the University of East Anglia. And this project is led by Harry Ewing, who is studying the curlew population in Breckland. Now, being up in Northern England, just a little refresher on where we are in Breckland. Here in East Anglia, where the headquarters of the BTO are based in Thetford. The last bird atlas, despite the fact that curlew were declining in quite a lot of areas of the UK, it showed rather a curious picture in Eastern England, contrary to declines elsewhere. And so it comes as a surprise to many people who associate curlew with sort of, upland moorlands and the Pennines and so on, that, wait, there are curlew in Eastern England? That's a bit strange because Breckland is often called like the desert of East Anglia or the desert of England. But yes, there are curlew here, quite a large population as it turns out. And Harry's project is investigating what factors are responsible for the apparent stability or maybe even increasing nature of the curlew population here on BTO headquarters doorstep. It's been remarkably understudied until this point. And it's specifically investigating curlew nest success, chick habitat use, and adult spatial behavior in Breckland. And this is just a map on the right showing Harry's primary sites in green, which cover a whole range of different habitats from Ministry of Defence land, including our RAF bases, the top picture on the left, private estates, which include quite a bit of arable land, and Thetford Forest as well. And the habitats can range from airfields to arable and dry heath grassland. And Harry, between 2019 and 2022, has monitored on the order of between 55 and 80 pairs per year across his study sites, and estimates, based on the areas that he has not been able to cover that have suitable habitat, that there could be as many as 150 pairs in the Breckland population. So this kind of shows all the areas of suitable habitat, which where curlew have been detected from other BTO survey data shown by the brown squares in the map, and then the green are just the areas which Harry's covering as part of his study. So this is kind of a typical day in the life of a PhD student. Kind of has quite a good deal really, from about the middle of March until early July. He's out every day, about 12 hours a day in the field. He's been incredibly hardworking over the last few years, surveying, looking for curlew pairs, and when he finds a pair, he will wait until they start exhibiting nesting behavior. When they start putting down eggs, he'll go and find the nest, measure all of the eggs, which you can see in that video, and he takes information on the characteristics of the nest site. And then throughout the nesting attempt, he follows how successful it is, and he relays, renests, and then if the chicks actually do hatch, he follows the chicks through till as long as they last, or until fledge, taking daily observations of what sort of habitat they're using. So a bit outdated now because I don't have his latest information from the 2022 season, but up until the end of last year, so 2021, he had found 136 nests. Unfortunately, the factors affecting curlew populations elsewhere are very similar in Breckland, so quite a lot of them failed, often down to predation, particularly by foxes, as shown in this video, and 52 of them hatched. But unfortunately, not all of those hatched nests go on to actually produce fledged young. Quite a few curlew are predated, curlew chicks are predated at various points during their growth period. And in fact, the probability of surviving incubation in Breckland, so basically surviving through till hatch for a nest, is only about 20%. So it's still lower than what is needed, but is perhaps a slightly better than other populations. So across the 3 years for which I've got the data so far for Harry's study, so 2019, 2020, which to be fair was curtailed by COVID, and 2021, hatching success was really consistently low across the years, hovering, as I said, at about 20%. And between all of his different sites, there was some variation in hatching success, but generally it was quite low across the board. And you see some of those higher ones, don't trust those because there's quite low sample sizes, not many pairs were found there. So it was quite difficult to draw any conclusions from those sites with very few nests. And while you might think that based on what I mentioned earlier about sort of taller, better structured habitat being having a positive effect on nest success, Harry did not find any particular effect of vegetation height on hatching success. So by and large, the height of the sward as measured across the bottom on the x-axis didn't really increase significantly anyways, the chance of surviving incubation. So this kind of indicates that, well, you can't really probably manipulate habitat too much. And to be fair, the vegetation in Breckland is a little bit, it's quite short across the board, particularly because it's so dry during the summer. But there were some sites with taller grass. But previous evidence from various other studies and other species does show that fencing at sufficient levels can boost hatching success. And while Harry did have some areas of fenced grassland among his study sites, there weren't really enough nests within this habitat to be able to draw out any particular effect, positive effect of fencing. So fencing, hard to say if it works in Breckland, but we know that it does work at other sites. And doesn't seem like you can do much in terms of vegetation height. So what else can you do to boost hatch success in this particular area? So what Harry found was that there's quite a lot of variation in the density of pairs across his study area. So the most number of pairs were found at Stanta and Honington, which are, hopefully you can see my arrow cursor on the map. So this site here is Stanta, that's an MOD site, a big training area in East Anglia, and then Honington, which is an RAF base here. And then we have Brettenham Heath, which is a heathland on a private estate over here. And those were kind of the sites which had the most number of pairs across all of his study sites. But you can see, so those are represented by the bars. But you can see the black lines here. Those indicate the density of pairs per kilometre squared. And you can see Brettenham and Honington, which I've outlined in blue rectangles, have quite a high density of breeding pairs compared to all the other sites. So they are, you know, between 10 to 15 pairs for Brettenham and over 20 pairs per kilometre squared at those two sites. So incredibly high densities, particularly at Honington. So perhaps you could target your measures towards high density sites, in particular, target fencing towards these high density sites. So Honington is an RAF site. It's a non-active flying base. It does have a fence around it, but it's not secure against predators. But if you were to, for example, this is all hypothetical, work with this RAF base to improve the integrity against predator incursion of their site fence, their perimeter fence, that could be a potential way of really having a very immediate and quite targeted impact on particularly breeding success at this particular site. So that's kind of Harry's reaching the ends of his PhD, and that's kind of where we're looking to next to continue on what he's learned. One of the other things that he's working on right now, so this is just what you could achieve with fencing. So you have about 30 to 35 curlew pairs, which currently produce about 40 to 50 chicks a year. With fencing, you could boost that to, you know, between 90 and 100 odd chicks per year. So almost doubling the chick output per year. So it could have a massive impact. So one of the other things that Harry is working on right now, he's making sure, looking at the influence of having nearby suitable habitat for chicks and the influence that that habitat can have on their ability to survive the brood rearing period. So whether you need a mix of vegetation in which to forage and hide, what type of vegetation structure and so on. So throughout the brood rearing period, he does daily observations and then weekly measurements of the vegetation height at randomly located points within each study site and within the territory of all the broods that he's watching. So that's kind of the watch this space for his analysis that he's currently working on in this area. So across all of his breeding seasons, he's monitored about 230 pairs. found over 200 nests. He's a phenomenal nest finder and has great fieldcraft skills. And overall has fledged about 54 chicks from his study side over 4 breeding seasons, which actually in the grand scheme of things isn't too bad, and probably is a lot better than many other sites which are able to fledge very few. One of the other things that his PhD is going to be looking at the spatial behavior of the adults across the breeding stages. So this little video is from a GPS tagged curlew from last year, 2021. And this is during the brood rearing phase. This was a female, and you can see the area where the dark orange dot is, and then is where her brood is. But the female kind of reduces her brood rearing earlier than the male, and you can see her reducing her brood rearing and kind of pinging all over the place, heading off to roost sites and so on, before she then migrates away from the breeding grounds. So we continued to put out some GPS tags this year, and we had great fun going out and catching curlew every day. And I have a small person who has come to say goodnight to me. So please excuse me for just a moment. She's a little helper often doing field work, so that's also really helpful. She's been coming out with Harry's project since she's been 2 years old. So we go out mostly in April to try and catch birds in the pre-nesting, pre-egg laying. And the next slide is going to show a little video of what it's like to try and catch curlew. And this is kind of a day in the life of field workers in East Anglia. So this is a pair that we're targeting with the kind of funny trap that you saw shown in the previous slide. You kind of, everything looks good, and you wait around and you get, oh, the curlew is going to come into the nest side, into the trap area. It's all looking good. And then you end up waiting around for 20 minutes while it thinks about whether or not it's actually going to come close enough to the feather decoys. They're stuffed feather decoys. And we play an audio lure to try and incite this male curlew, in this case, to run at the decoys and then trigger the clap net, in this case, and be caught for tagging.
Harry's in the shot.
So it's quite helpful if there's a quite territorial bird and you're really within the territory. You can elicit quite a territorial response. So once we catch the curlew, we then metal ring it, take measurements and put color marks on, and then put on one of these fabulous GPS tags. These connect to the mobile phone network and can basically deliver data straight to my computer every day throughout the breeding season, and also on migration as well. The curlew then goes into a box to kind of just rest and check that the harness fit is okay. And then after about 5 or 10 minutes, when we decide it looks fine, and we do one last little check of the tag, and then off it goes. And hopefully it will continue to deliver data. So this is all looks very exciting and very promising. And the tags are amazing when they work well. But unfortunately, sometimes you get a duff batch of tags, which was the case this year, through no fault of the tag manufacturer. Their supplier of SIM cards provided a kind of a duff batch of SIM cards. And so the connection of these tags to the mobile phone network has not been wildly fantastic. So that has been a bit disappointing. But fortunately, we've got data back from some of these tags, and they've shown some really interesting migration behavior as a kind of bonus, in addition to what the birds do during the breeding season, which was what we're really interested in. So in a little animation on the left, you can see one of the birds, which was caught at a roost site on the breeding grounds, and it headed off to Cumbria at the end of the breeding season. Probably failed because it left quite early. It left about early June from Breckland, and then it hung out at the head of the Solway for a good month before pinging around to other various sites further out on the Solway, heading out towards the Mull of Galloway. And then just earlier this week, we found this bird had headed over to Ireland, completely unexpectedly. Curlew are known for being really site faithful during the winter. And so we think this must be a young bird, not a second year bird, but because it wasn't, Curlew don't usually come back to the breeding site in their first available breeding year, but they usually come back in their second available breeding year. And it wasn't obviously young, but clearly not mature either, and perhaps still working out where it was spending the winter. And then the map on the right shows two other birds from breeding site, one in yellow, which is wintering on the Blackwater estuary in Southern Ireland, and then the bird in purple, which after migrating down to an estuary in Essex, surprised all of us by heading down to Portugal to spend the winter, where it stopped over briefly in the Tagus estuary before popping down to the next estuary south of that. So a lot of really exciting bonus data that comes from these tags. And the curlew from Brackland, both from the tags, but also from the reciting that members of the public or bird watchers have made of some of Harry's colour marked birds, have really shown that birds from the breeding areas in East Anglia can kind of end up a little bit all over the place, with these blue stars just showing some of the locations where birds spend the winter. So our second project in Eastern England is an innovative partnership project, which is led by Natural England and includes BTO, Pensthorpe Conservation Trust, WWT, the Royal Air Force and the MOD, and Wild Ken Hill and the Sandringham Estate. So as I mentioned earlier, there's a lot of information to suggest that poor breeding success, that is nest and chick failure, are behind the declines of curlew in the UK. And there's a whole bunch of conservation tools, which I've both directly and indirectly mentioned earlier, that are being used to boost breeding success, including habitat management, nest fencing, and predator control. But there's another tool, which is the one I'm going to talk about now, and that is head starting. And the definition of head starting is you're taking eggs out of the wild. This doesn't have to be for curlew only. This can be for other species. They've done this for Eurasian crane in the UK as well. So you take eggs out of the wild, and then you rear the eggs and then the hatched chicks in captivity, and then you return the birds and release them back into the wild population. So you're kind of taking the eggs and the chicks out of the riskiest period of their life, giving them a head start, literally, in captivity, and then putting them back into the wild population. So many UK populations have a fledgling success in the wild of about 0.2, 0.3 fledglings per pair per year. So that's about half of what's needed. But if you instead take 4 eggs into a clutch of 4 eggs into captivity and you rear them, you might expect to release up to 3.2 fledglings per clutch per year. So that's a huge boost to overall productivity per year. So when might you want a head start? And this is some sort of rough modeling work that's been done by Jeff Hilton at WWT to demonstrate a couple of different scenarios. So in the first scenario, you've got a declining population over time, and you might want to literally buy time for it. So over a period of 5 years, shown in yellow, you do head starting. And there's a relatively big effect when the population is small. So you're kicking it back up to a level that can buy you time to implement other conservation measures, whether that's habitat management, controlling predators, or what have you. In the second scenario, you have a very, very small sort of native population that's kind of just ticking along at 5 or 10 pairs in this case. And you do head starting again for a period of 5 years. And then in this case, you're just boosting it above its natural population growth trajectory. So you're giving it a big head start by boosting it up with head starting to about 40 pairs from about 5. So given that you have a huge per capita impact on productivity, why wouldn't you want to head start everywhere? Well, it's quite expensive. It requires a lot of staff resource and training, as well as specialist equipment. It can be very difficult. It requires quite a lot of avicultural skill to implement well. It can be quite risky. So you have literally all of your eggs in one basket. So for example, if you have an outbreak of disease, or if you have a predator get into your rearing pens, it can completely wipe you out for 1 year. And finally, the numbers that you can fundamentally return into the wild population are limited by resources in every single year. So this might limit you to about, a few tens to max 100 or 200 birds per project. And beyond that, it gets quite prohibitive. So there are currently 5 head-starting projects ongoing in the UK. There are other head-starting projects in Ireland, Belgium, Germany, and Poland as well. And it's a sort of conservation management intervention that's really gaining quite a lot of traction and interest. And each of these projects in the UK, they all have their own rationales for head-starting. And I'm just going to focus on a single one in this case as a case study, which is the one that the BTO are involved with in Norfolk. And this is this big partnership project, which is led by Natural England. So in this area of England, airfields, and particularly military airfields, provide really ideal curlew breeding habitat in what is largely an arable landscape in eastern England. But adult curlew are very big birds. They pose quite a risk to military aircraft through aircraft collisions. And so historically, eggs have been destroyed on particularly military airfields, but also civilian ones for flight safety reasons. However, head starting presents a really quite viable conservation alternative to egg destruction. And you get the young birds released back into small isolated populations. We can have a big conservation impact. And so in 2019, Natural England, together with the WWT and the RAF, they trialed removing eggs from 5 airfields from the east of England. And those eggs were taken into captivity at WWT in Slimbridge in Gloucestershire and reared and then released back into the local Gloucestershire population in the Severn Vale. And it was shown that head starting could be a viable conservation management tool for curlew. And so in 2021, the project was expanded to more airfields. But instead of being reared across the country in Gloucestershire, the eggs taken from airfields were reared in East Anglia, and then the resulting chicks were returned back into the East Anglia population. So this was Harry's study site down in Breckland. And the Norfolk Head Starting Project extends this area northwards into West Norfolk, which has an isolated, quite small, but existing curlew population of between 2 and 5 pairs. So that's existing population is shown here in this little blue oval at the bottom of the map. So this estuary is the Wash. And the map shows in the white rectangle the release area in West Norfolk, which borders the east shore of the Wash. And the blue stars on the map show the 2 different release sites. So the one in the top left is the Wild Ken Hill site. The one to the right is this year's Sandringham release site. And this pale orange star shows last year's Sandringham release site, which we decided wasn't as suitable as it could be for release in terms of the habitat, and it was also quite close to the Ken Hill population. So we decided to look for a new release site this year, and we're very happy with one we found now, just south of Great Bircham, which is an area of wildflower conversion in Countryside Stewardship Agri-Environment Scheme, and so provides some really good prospective curlew habitat when birds return to breed, well, when we hope they return to breed, because it will be in the wildflower option in this agri-environment scheme for about 5 years. So good prospective potential breeding habitat for any returning birds. And these 2 different release sites also have sort of different landscapes, and we kind of expect curlew to do different things when they're released at these 2 different sites. So more on that in a moment. So over the last 2 years, eggs get collected from airfields by Natural England and RAF staff, and they're taken into captivity and put in incubators until hatch at Pensthorpe. And they're then raised indoors under heat lamps for about a week or so before they're getting transferred to the outdoor aviaries, which you can see in the video. And they're in those outdoor aviaries for about 4 weeks until they can fly. In 2021, we raised 106 eggs, and in 2022, we had only 58 eggs this year from airfields. So many fewer, whether that's because birds were less successful or because RAF staff were less successful at finding nests. We're not entirely sure. It could be a little bit of a mix of both. So after birds can fly, they're moved into this other pen at Pensthorpe until they're about 50 days old. And it's at this point when they're moved that BTO staff get involved, and we come along and we ring them, and we put the color rings and flags on their legs that you can see, the little yellow flag that this chick is wearing. And then at about 50 days old, the birds are transferred to their release site, which is when they might get a GPS or radio tag. So this is an example of one of their release sites. This is the release site at Wild Ken Hill. This is the release site last year in 2021. It was not nearly so wet this year. In fact, there wasn't a speck of water to be seen this year. We drive them over in cardboard boxes in the back of the pickup truck. And before they get put into the release pens, where they'll spend about a week acclimatizing to their release site, they get either radio tagged or GPS tagged by BTO staff, and that's a subset of birds will get radio tagged and GPS tagged, and that's so that we can look in a little bit more detail at their movements post-release. So what have we found so far from this project? In 2021, I mentioned quite a lot more eggs were collected from airfields, and we released nearly 80 individuals between Sandringham and Ken Hill. And in 2022, many fewer eggs collected, and we had poor hatching success of those eggs. And so only 37 birds released, but of those 37, they're returning very interesting information so far. So all of the birds, as I mentioned, are color marked with these yellow flags. And this allows sightings of these birds to be made post-release. So there's a web form that members of the public birders can enter their sightings in, and that comes straight to the BTO. And as of about sort of early mid-September of this year, 28 individuals from last year's release, so from 2021, have been seen post-release. Most of those have been around the Wash, mostly on the east shore of the Wash, but a couple a little bit further afield in either Lincolnshire or Norfolk. We had one regularly sighted individual as well on the Exe estuary in Devon throughout last winter. So the individual color flags are really quite useful, but the radio tags and the GPS tags provide another layer of information. And so radio tags have been really helpful, telling us about how long birds stay around the immediate release site. So you go out to visit the release pen area every couple of days and listen using this antenna that Jasmine is holding above her head, listening for the different tagged birds and seeing how quickly they disperse from the immediate release site. They've also been quite helpful in telling us about local mortality, so leading us to unfortunate predation events like this one. And a lot of the predation events we've found have been raptors. And then the GPS tags have added an additional layer of information on top of that. So these are the same type of tags that I showed in that video earlier that we were putting on the Brecklin breeding curlew. These are a slightly different model that are a bit smaller and better suited for juvenile birds. And these have provided some really detailed information about what birds are getting up to post-release. So after a small trial last year to make sure that juvenile curlew were suitable to be tagged, we were able to expand that tracking study this year, and we tracked 12 different birds split between the two different release sites, and this will just give you a little flavor of what birds get up to. So in the purple colors on the left of the map, you have the first birds that were released at Ken Hill, and in the blue colors, the first birds released at Sandringham. And you can see the Sandringham birds kind of spread out away from the release site quite quickly and kind of do a few different things. The Ken Hill birds stay quite close to the release site, occasionally shooting off for a little exploration. Often they explore together as a cohort or with another bird from their release cohort, which is quite interesting. And the Sandringham birds are kind of spread out, and some of them are still where they're located even now. And so now you've got this green bird, which is from the next set of the next cohort of Sandringham and Ken Hill birds, which is shot off to the Great Ouse, the mouth of the Great Ouse. And you can see some birds have stuck around on the east shore of the Wash, and they're still kind of moving together. But at a certain point post-release, they start to get a little bit more adventurous and they start spreading out. You saw one that just shot off the left side of the map, which we'll see more about in a moment. And so this map, this little animation goes through until just the beginning of September, I think. And a lot of these birds are still kind of where they are at the end of this animation on the 1st of September. They're still there even now, having kind of settled, if you like, into a wintering location. So that bird that shot off the edge of the map is this one, 6Y. This was part of the first release cohort at Sandringham. And you can kind of see the little orange dot there in Norfolk for a couple of days, and then it decides it's moving. It shoots off to Ireland, does a little big old loop over the Irish Sea before settling down, thinking better of it, which is very good of it, to settle down on the south coast of Ireland at Ballyteak. And then this other bird migrated nearly a month later after 6Y. Again, you can see it where it hung out at its site on the Wash for quite a long time before heading down to the southwest off the coast of Cornwall and then heading down to the coast of Brittany, where it is now very firmly located on the north coast of Brittany near Roscoff. This is just a little graphic showing the movements of all of the birds which have stayed near the Wash so far. You can see most of them have stayed on the east shore, but a few of them, including this bird on the far right of the middle row, which seems to really like this sort of presumably tidal pattern commuting between the North Norfolk coast and RAF Sculthorpe, which is another RAF base. And some have headed over even to the west shore of the Wash in Lincolnshire, like this bird, the top row and the rightmost bird. So what next? There's a lot of questions we still have to answer to find out if this will be a successful conservation intervention. So do released juveniles behave similar to wild juveniles? We hope they would. Is survival on par with wild juveniles, particularly, and with adults as well? And again, for a successful intervention, we hope that it is. And the real proof of the pudding, if you like, is the extent of local recruitment. So if the aim of using head starting as a conservation intervention for curlew is to boost a local population, you have to have those release birds returning into the local population to breed. It won't really do if they scatter out into the wider landscape, whether that's throughout sort of southern England, the UK, or even abroad potentially. It's not going to serve the goal of boosting local breeding success at all and boosting the local population. So that is what we aim to do over the next 3 to 5 years of the project, which is start doing surveys of the release area. We expect the first returning birds from 2021 to start returning next year in 2023. So to start doing surveys in sort of concentric circles, if you like, extending out from the release sites to look for potential returning breeding birds. So there's a lot of interest in head starting. Where's it going in the future? I think people think of it as a bit of a panacea. And they have to remember it's just one tool in the curlew conservation toolbox. You really need to have a comprehensive recovery plan in mind, and also comprehensive post-release monitoring is really vital to be able to assess the success of the head starting program. There's no point just, throwing birds out into the wild and then doing no follow-up after that to find out if they come back to breed. And one of the things that I and other people who are interested in head starting hope to work on in the coming year or so is almost a handbook of head starting, if you like, which contains best practice guidance for other people who are interested in head starting other projects. So moving on to the just final bit, which, sorry, has gone a bit over time, I think. We've also been working with stakeholders to engage them in wader monitoring. And this has been work that's been primarily led by my BTO Scotland colleagues, John Calladine, Mark Wilson, and David Jarrett, and also by Paul Noyes, who is our wader project officer, and who I'd particularly like to recognize for the incredible work he's done over the last year and a half since he's been in post to carry out these elements of our breeder wader monitoring and engagement work. So some of the work that's come out of this is a really quite one of the most useful tools, if you like, has been the Wader Abundant Zone Mapping Project, which is a tool to guide government plans for woodland expansion while minimizing the adverse impacts on breeding waders. So to meet our climate change targets, Woodland planting will be a key way to do so, and we can all acknowledge that woodland is a good way of reducing our carbon emissions and capturing carbon. But those trees have to be planted in the right place, because we know that breeding waders and trees don't really get along that well. And the wrong tree in the wrong place might negatively impact in various ways our breeding wader populations. So this used citizen science data from Bird Atlas and BBS to do some really fancy modeling to produce these maps of wader abundance at predicting wader abundance at each 1 kilometer square in Britain. And these are some example maps that have been produced for lapwing, golden plover, and for curlew. And the predicted outputs were pretty good when you consider that they were made with Atlas data, and then they were basically calibrated or validated against other types of data. So against BBS data, you could see how well they matched up, and they did a pretty good job. So these are looking at those maps in a little bit more fine scale resolution. You can see that wader abundance is separated out into 5 different strata, where you have these red sort of the hot zones, if you like, are the areas with the highest abundance, and the blue-gray areas are the areas of lowest abundance. And so these correspond to different numbers of birds per kilometer squared, these different strata. And loads of potential uses for these wader abundance maps. It can be used to target wader conservation in terms of deploying agri-environment in particular areas. It can provide some really sort of high-level guidance to steer certain development opportunities away from important areas. So in particular can be used to guide forestry away from wader hot zones, be used to guide wind farms, onshore wind farms away from wader hotspots towards areas which are will be much less negatively impactful, and can be also quite useful for local planning authorities, for example, to determine the levels of scrutiny associated with any developments. So any developments, for example, that are proposed within an area which has hot or warm wader abundance areas might be requested to do some much more intensive survey and pre-application survey work to determine the impact of any development if it is likely to impact in a hot zone. So these maps are freely available on both the Forestry Commission website and also on the BTO Wader project map at the address below, where people can access the data and a lot of other information besides about how the data were produced. One of the other things the BTO are interested in doing is expanding our wader monitoring capacity. So while the Breeding Bird Survey does a very good job about telling us about changes in annual abundance of waders at a national scale, it doesn't necessarily do a very good job at targeting the particular reasons. What are the causes of those changes? And so that is something that we're looking at expanding on in various different ways, engaging a non-traditional set of prospective surveyors, if you like, including farmers and small landowners through our wader calendar survey, game bird estate workers through Gamekeeper Transx, and also our traditional set of supporters, BTO volunteers, volunteer surveyors through Breeding Bird Survey and Waterbird Breeding Bird Say, special wader visits, which are tacked on as a third visit on the end of the normal breeding bird survey seasons. So just an example for the wader calendar survey. It's kind of also often referred to internally as a little and often wader recording method, which has been trialed over the last 3 years now. It's kind of a new data set, particularly targeting farmland waders and increasing farmer awareness and engagement with waders. So it's basically takes place on a weekly basis, where farmers basically just tick off whether any of the whole range of wader species has been seen, detected, how many, if they choose to record that information, and whether any of the birds that they've seen are displaying alarm calling behavior, so behavior that might be associated with brood rearing. And there is definitely some indication from some preliminary analysis that the wader calendar approach does potentially a decent job of giving broad indications of curlew chick rearing across the different periods of the breeding season. So this is the key information we're kind of trying to get out of these different approaches, is a way at estimating through our various monitoring approaches what productivity is like at a national scale, because that is kind of the key piece of the jigsaw that's missing. So gamekeeper sound checks are a way of obtaining more information about wader productivity on really extensive ground that's quite difficult to survey through our other sort of more traditional means, particularly in areas that aren't well covered by volunteer citizen scientists, and trials of gamekeeper data against professional ornithologist data have shown that there's quite a good match between those. And then I mentioned these breeding wader visits tacked on to the breeding bird survey. So these are additional visits at the end of the season, timed to be able to look at whether or not breeding bird surveyors detect any indication of alarm calling adults, which would indicate the potential for chicks to be present. And there's sort of promising preliminary results so far, and we're digging into this a little bit more with the breeding bird survey data this year. I mentioned the wader project map in relation to the wader abundance zonal mapping earlier. And the aim of this particular project is to really be able to foster collaboration between projects. People can really easily see different projects in their area. Independent projects are able to enter a little bit of information about what they're doing and their aims and what type of data they might be collecting. So just a way to facilitate different projects working together and to provide a bit more of an oversight of the wader conservation and project landscape in the UK. So the wader project map contains, as I mentioned, a layer which shows the different wader abundant zones, and also these little blue place marks which indicate the locations of different wader projects on the go currently in Scotland. So working in partnership, as I've kind of hinted at throughout this talk, is really key to success, and that is both sort of top-down coordination, but also bottom-up support and action. So there's a lot of sort of grassroots support for curlew and wader conservation. And what we've learned is that provided the right tools, stakeholders can become a really integral part of the monitoring process. So these are stakeholders like farmers and gamekeepers, which might not have traditionally been seen as engaging in the sort of bird conservation landscape previously. But this really gives them quite a lot of ownership of the outcomes and the decision-making process, which might ensure that A, there's belief in the evidence that comes out of this, and also that the communication of the outputs is shared to the right people, the people who are going to be implementing sort of interventions on the ground. And this is really going to require partnership across all levels and sectors. And so just one of the examples of BTO's action in this area is a new project we're going to be undertaking both in this last year and also next year. It's a farming and protected landscapes project together with the Yorkshire Dales National Park Authority. And this is using different approaches to wader monitoring with the aim of feeding what we learned back into the environmental land management scheme, which is the new, hopefully not off the table, the new agri-environment scheme proposal, which is on the table to start in the next couple of years. And so this is using new approaches like acoustic monitoring, and having farmers put out these acoustic monitoring devices and doing wader calendar surveys, and also looking at habitat use across different landscapes within the Yorkshire Dales, particularly comparing how birds use more silage-based landscapes to more haylage-based landscapes, and how they differ in their movements, both at the valley bottom in Wensleydale and other parts of the Dales, and moving up the slopes of the Dales up to the moorland tops. So this is work that we're going to be looking at more in the next couple of years, so stay tuned. So where next? Well, all of these different approaches and projects have value on their own, but our intention is to make sure that these outputs don't remain isolated, but they're harnessed into a wider overarching system, if you like, where this information can be both collated for individual projects to use and to look at their outputs and sort of summaries about their results and their monitoring efforts, but then also disseminated out into the wider landscape as well, whether that's to policymakers, to members of the public that are interested in these different projects, and also to local stakeholders who will be implementing these conservation management projects on the ground as well. And hopefully this is creating a shared vision and evidence base that can be used for decision making across all different sectors of wader conservation. So that's it from me. I'd definitely like to thank all of my colleagues at BTO who contributed to the various different threads of work that we've been doing over the last nearly 8 years now. The PhD team at the University of East Anglia, the Eastern England Head Starting project, and the many volunteer surveyors and stakeholders who've contributed to BTO's work and funders as well. So I will stop there, and apologies for going on a little bit long, but hopefully you will find it was worth it. And I'm very happy to take questions.
Sam, thank you. I initially didn't spot that you were overrunning because I was that absorbed, but then when you mentioned it, I thought, oh crikey, but it had such a nice flow to the presentation. I didn't really feel I could interrupt, and the audience has stuck with you. I will say, if people do have to go now, we are recording this and it will go on our website in the next few days. So if you have to disappear but would like to hear the Q&A, you can come back to it there. So hopefully by the end of the week or thereabouts. We've got a few questions that we'll try and dash through what we can. I'll also just check, Sam, while I remember. Are you all right for me to share your email with Clive White of the Darley Curlew project?
Yes, please do. Although it's my colleague
project that's been going on this year. So
yeah, I'll probably end up pointing you to Paul Noyes, our Wader project officer. Yeah, but yes, please do. Yeah, I don't know if Paul knows about that project.
Sure, it's not dissimilar to the Yorkshire Dales National Park one, but it started a year earlier.
Grand.
So a few questions. The first is about the intelligence of corvids learning where nests are. And certainly in the Darley project, one of the steers we had was not to visit nest sites because they'll see you going and realise there's something there. Harry was clearly going to the nests. Was there any evidence of predators learning either through scent trails or visual?
Yeah, so there's a lot of debate and discussion in the sort of ground nesting and wader research communities, not just in the UK, but also abroad as well, in Europe, Iceland, North America. Do nest visits increase the likelihood of a nest getting predated? And the overall evidence summed up is no, it doesn't. That's not to say that in certain cases that might not be the case. I think Harry has largely found that the most vulnerable stage for nests, particularly to corvid predation, is pre-incubation, when a bird has not started, when the adults have not started incubating yet. So it's that sort of up to the third egg in the days leading up to the start of incubation when nests are most vulnerable to predation. And he's found that many of his nests are predated in this sort of pre-incubation, post-laying phase, and that birds will very quickly turn around a new nesting attempt quite quickly. Ideally, obviously, you wouldn't want that to be the case. But very rarely, I think, is the evidence largely points to nest visits not detrimentally impacting nest success and likelihood of the likelihood that a nest gets predated.
Thank you. Not definitive, so
yeah, it's a tricky
thing.
one.
Yeah.
I mean, it's kind of like everyone should aim to follow the sort of nest record scheme code of best practice. So don't follow the same trail that you always do when you go to visit a nest. Ideally, monitor it from a distance if you can see the adult bird still sitting and so on, and only visit a nest if you have to. If you can, use a remote monitoring approach like a temperature logger or a nest camera or something of that nature. And just reduce visits to the bare minimum needed to monitor the nesting attempt, basically.
Sure, thank you. We'll jump around a bit between different subjects on this, so keep your mind sharp. How long do the adult birds tend to live once they've reached, got past the vulnerable years?
Yep. So I believe the current age record, longevity record for curlew is a new one set this year, something on the order of 31 years. So they're an incredibly long-lived bird. There is some worry that because of low breeding success for such a number of years in the recent decades, that we have an aging curlew population in the UK. I don't know how much evidence there is to bear that out. They are a very long-lived species, and there is no known evidence that their breeding success declines with age. But it could be that is one of the reasons why we kind of feel like we're seeing the declines that we are, and that we might even see a hastening of declines, is that existing birds are kind of reaching the end of their natural life, if you like. But there's no new birds coming into the population.
Sure, thank you. You mentioned about the mapping and avoiding areas for onshore wind turbines. Is that an issue because of strikes or disturbance, or?
More the latter than the former. It's much more about ground-based disturbance during the construction phase. Obviously not so much of an issue in England because there's been no onshore wind here for quite long, well, since David Cameron, but could become an issue in the future. And offshore wind obviously becomes an issue when you think about the migration period and the interaction of migrating curlews, both our breeding birds to elsewhere, but also birds that come here to spend the winter from elsewhere on the continent, and their interactions with offshore wind. So lots of things to think about in terms of how birds might interact with all of the sort of human anthropogenic features in the landscape that we've imposed on them.
Sure. The final sort of group of questions I'll just touch on relate to predators. Fencing, I think you mentioned, but would presumably only relate to ground predators rather than avian. And also sort of released game birds. So pheasant, could be grouse, more management as well, but perhaps more likely to be pheasants. Perhaps supporting predator numbers, which then also have a impact on curlew. Is that a likely?
It has been one potential route that can have an impact on the number of predators in the landscape, and if there are more game bird releases in certain areas, is there greater likelihood of predation of ground nesting birds in those areas. That it's kind of like a bit of evidence here, a bit of evidence there, no one's entirely sure. So BTO did a piece of work a year or two ago now, looking at the relationship between game bird releases and the abundance of different predators, and found kind of inconclusive evidence to suggest there was in some cases, but not in others. It's a very tricky one to get a handle on, and one that one that people are talking about all the time. And it's both in the conservation sector, but also in the game bird shooting industry as well, as a potential reason. I think it's widely acknowledged as being definitely a potential cause that's on the table for discussion.
Thank you. Not so much predation, but the disturbance and impact on chicks. Has any group had success with influencing farming cutting timetables?
Yeah, that's a tricky one. I think in a lot of areas, particularly groups. So I'm thinking the Curlew Country project in Shropshire and the Welsh borders is a good example. They've worked very closely with farmers over the last, 5 years of the project now, and have developed good relationships with many of the farmers within their study area. And farmers are very keen to do the right thing, but when it fundamentally comes down to their livelihoods, it's very difficult for them to sacrifice crops if it will mean like basically sacrificing a very important part of their income for the year. So while they want to do the right thing, the economic compensation mechanisms are not in place yet to enable them to do so without sacrificing their livelihood. And so those two things haven't caught up with each other yet. And we're hoping that, that might be incorporated into some elements of the environmental land management scheme appropriately. But, it's still the early days and we don't know whether that'll be the case or not.
Yeah, thank you. Do watch this space though, because part of the Darley-Beck Curlew project is indeed to try and assess whether there are ways to influence that. So I can almost hear Clive White of that project shouting at the screen at the moment. But I'll put you in touch with Clive separately.
Yeah, please do.
Apologies to those if I haven't quite covered all aspects of their questions. I think I've got most of them, but it is 10 to 9 and we should let Sam go the way of her lovely daughter who gave us a great cameo earlier. So I would say more effusive thanks, but that's Helen's job. So I'll pass you back to Helen, Sam, and thanks ever so much.
Well, it isn't going to be difficult for me to give very effusive thanks, Sam, because what a wonderful talk that was. Absolutely fascinating, stuffed with information, some of which, I'd really just never thought about before. The thing about Britain having that surprisingly large number of mesopredators, I'd never known that. That's something I'm going to go away and think about and wonder about. Very, very fascinating. And I really enjoyed the way that you took us from despair to hope as the talk progressed, because the numbers that you started with are just so stark, so frightening. But then, hearing about the various projects that you've been involved in, Harry's PhD project and all the others, it does stand to reason that kind of research is going to take us somewhere, and that the fortunes of these various birds, and perhaps especially curlew, are going to get turned around eventually. So thank you not only for the talk, but also for all that work that you do, because it means a great deal, I know, to all of us who are sitting listening to you tonight.
Thank you very much for having me. And if anyone has follow-up questions that they want to email to me, please just get my email from Jeff or Helen. Very happy to try and address them.
Thank you, Sam. I might just mention one or two things very briefly, Jeff, if you don't mind. Just in particular, of course, it's the 75th anniversary talk by George McGavin on Tuesday, next Tuesday, November the 1st. So if you haven't already booked your place, I gather there are a few left. Please get in touch with Peter Riley to do that. And those of you who've already booked your place, don't forget to come on the night itself. There's also a birding walk this weekend, Saturday, led by David Smith to Eckert Reservoir. I can't myself go, very unfortunately, but I've been to Eckert with David many times and it never ever disappoints. So if you're at all interested in birds, do turn up to that. Okay, well, thank you very much for joining us. Thanks again to Sam. And I hope I shall see many of you at the George McGavin evening next Tuesday. Thank you.
Good night, everyone.